Hello guys, today I'm going to start the third part of this chapter, elements, compounds and mixture of this chemistry chapter from class what? 6, obviously, yes. So now we have already studied about the elements and the compounds. Now the third part is about the mixtures. Okay, so let's see what are the mixtures now. A mixture is a substance which consists of two or more elements or compounds not chemically combined together. Okay, a mixture, what you can say that this is just a substance, okay, which contains many elements together. Elements we have got already about how much elements we have got? 118 elements we have talked about, isn't it? That is present in our periodic table. And so from those elements, these mixtures are what? It consists of two or more elements together or compounds. Compounds also we have got, isn't it? We have discussed about compounds, but they are not chemically combined together. Those are the mixtures. Mainly an example, this air, isn't it? Air we know. We breathe air, we breathe the oxygen. So now what is oxygen? How much oxygen is there in air? Actually the air is a mixture of some gases. So what are those gases? See on the next picture. This is nitrogen is how much? 78, the highest. Okay. Oxygen which we take it, that is only of 21%. Carbon dioxide is 0.04% and some other gases are there. Mostly the argon is there of 96%. 0.96%. So this is a mixture. So what you can say that air is a mixture of some gases. Okay. So let's see the next one more example of the you can look in front of you a cup of tea. Okay, so this cup of tea is what? There's a mixture of milk is there, tea leaves is there, sugar is there, water is also there. Okay, so this is also one mixture of the one substance. Okay, many mixtures are there, many substances are there together. Okay, next slide, what we will see here, we have seen about one bowl. The first picture, there's a mixture of some fruits and berries with some flakes in a bowl. Okay, and the second one we can see some candies and some sweet gums is there. Okay, I think this is very delicious to see with you all. No, both the diagrams are very tasty for you all, isn't it? So this is also an example of the mixtures, means all are mixed together. So there are some characteristics of the mixture. What are those characteristics? The constituents of a mixture may be present in any proportion. The constituents of a mixture can be separated by simple physical methods. Means physical methods means just simply by hands or anything. Okay, means not chemically. It can be separated. The mixture does not have any specific property. In a mixture, each constituent exhibits its original properties. Whatever properties there, it will originate in there only. Okay? And the mixture does not have a fixed melting or boiling point. So you can't say that this mixture has this much boiling point. So it doesn't have any fixed melting or boiling points. Now as we have studied this, all the mixtures and characteristics of mixtures, we should know that there are some two types of the mixtures. What are they actually? These are homogeneous and heterogeneous mixture. Okay, now what is homogeneous mixture actually? The homogeneous mixture is a mixture in where the components are uniformly distributed, okay, throughout the volume and cannot be seen separately. We can't see it separately. And whole the mixture is totally uniformly, means all the particles is there uniformly distributed. Like what? Tea, isn't it? We can't differentiate that this is milk, this is tea leaves. Okay, all are together uniformly distributed. Fruit juice, medicine, honey, milk, blood. Okay, these are the homogeneous mixture. We can't see them separately. And what is heterogeneous mixture? This mixture is in where components are not uniformly distributed. Like just now you have seen the cornflakes, okay, flakes in the bowl and the candies. Those are heterogeneous mixture. Means we can just slowly by physically methods we can separate it. Okay, like ice and water, we can just remove the ice from the water. Soupy noodles, noodles and soups, both are two different, we can just separate it. Then candies, assorted dry fruits, soil, and from soil also some many other earthworm, or if plastics are there, we can just we can remove it by physical methods. And even oil in water, if you see, we can differentiate that this is oil, this is water, isn't it? So we can see them very separately. So this is heterogeneous mixture. So there are two types of mixture. Again, I'm repeating, one is homogeneous, which are uniformly distributed and cannot be seen separately, and heterogeneous mixture, they are not uniformly distributed and can be seen separately. Okay, so let's now see some mixtures of what? Iron and sulfur. So iron and sulfur, what is that mixture? Iron is a metal, sulfur is a non-metal. Now if magnet is there, magnet will always attract a metal. Okay, so this mixture can be differentiated how? By using the magnet, we can again separate the iron from the sulfur powder. Okay, but if this same iron and sulfur is heated, what happens? See here. What will happen? If this iron and sulfur is heated, we will find it iron sulfide. We will get FeS. Fe is a symbol of iron, S is a symbol of sulfur. Both are solid state. On heating, we will get a brownish substance, that is the iron sulfide. Okay, this is a new compound we will find from iron and the sulfur. Okay, this iron and sulfur will have every properties in both the component. Okay, and by applying many suitable physical methods on these properties. Okay, so these are one more example of a mixture. Now let's see, then if FeS is a compound, so now compound and mixture will have some difference. What are those? Okay, let's see. Compound are what? They are formed on combination of two or more elements, and mixture are formed when elements in compounds are together. Okay, properties of compounds vary from their constituent elements, and mixture show the properties of the constituent compounds or elements. Number 3, components of compounds cannot be separated physically. Example, distillation, filtration, and mixtures components can be separated physically. Compounds are always homogeneous mixtures by nature, and mixture can be homogeneous or heterogeneous by nature. They show their own characteristics, they don't show their own characteristics present in a fixed ratio of a compound, and ratio of mixtures vary. You can't keep in a single ratio, you can't put it all the mixtures. Okay, in a particular compound, the boiling and melting points will be constant, and in the mixtures, boiling and melting points are not constant. So these are the differences between what? The compound and the mixture. Now these mixtures, we are talking about mixtures, but these mixtures are sometimes not good for us. Then what we will do? Then we have to separate them. Okay, so why this separation is essential for these components? Because we have to remove some unwanted components. Sometimes we have to remove some harmful components, and to obtain a very pure and useful component, we have to separate this mixtures. Okay, sometimes what happens, some eatables or other materials we get from the nature, what we do? We have to remove it. Like we have some in a dish, you have some rice with some stones. What you will do? You have to remove the stones, isn't it? Before cooking the rice, we have to remove the stones. Okay, so there on the next video we will study about some methods of separating these mixtures. So how there will be some methods of separating these mixtures, we'll talk in the next video. Means there is a 4 parts of this chapter. Okay, so the 4th part of the chapter will talk about the method of separating the mixture. Till then, thank you.